This is a test just to verify that everything works properly at 3.3 volts. So I have that set on the power supply over here, measuring it with a multimeter just to get a more accurate reading. This multimeter is measuring the current. When it's at about 9 milliamps, that means everything is awake. And in sleep mode, it drops to about 3 milliamps. That'll be lower once everything is optimized, as you can see there. And on the board, I'm currently just using an Arduino Nano. I'm not even turning off the radio. So there's a lot of optimization that can be done to get this maybe into the sub milliamp region, microamps. And on the oscilloscope, I am just measuring. I have a pin set up to go high for 50 milliseconds every time it sends a packet. So in a previous image, I showed that there's a 20-second duty cycle for each transmission. And over here, I'm just zooming into the pulse a little closer. And one thing I've noticed is not too significant, just that when the microcontroller is awake and the pin is low, it's sitting at about 240 millivolts. And then once it goes to sleep, it goes down to about 120 millivolts. So that's just an indication for me when I'm looking at it on the scope, exactly when the microcontroller goes into sleep. It's currently sleeping for 8 seconds because I'm just using the built-in watchdog timer. This chip over here is an RTC, real-time clock, which I will eventually use for setting a timer to wake up every 5 minutes, maybe 10 minutes. I don't know that yet, but I think that is all there is to say right now. I'm going to continue to test the power consumption in this almost fully integrated state. And once I'm satisfied with that, I will move on to miniaturizing it and trying to fit everything onto an Arduino Pro Mini, which is this over here. This is my modified one, which I talked about in my blog. As you can see, it's missing the voltage regulator and the power LED trace is cut. So this can get down to about 5 microamps. And if I turn off the watchdog timer, which is what I'm using right now to sleep for 8 seconds, I can get that down to 100 nanoamps. The clock itself uses 45 nanoamps. The sensor also uses something in the microamp range. Like I said, I can turn off the radio. So yeah, there is a lot of power savings to be gained here. And I'll continue working on that for the next few days. That's all.